So welcome back. We are in part two of signal flow graphs and Mason's gain formula. We did the difficult part earlier. Now we'll do the interesting part. So we have seen some definitions and terminologies. So let us go on. Let us eat the cake. So consider the signal flow graph given here. So this is a graph. You saw the graph. You have to identify the forward paths, forward path gains, loops, loop gains, and non-touching loops. Is the question clear? So just pause for a while and think about it. So there is one forward path. So let me choose the forward path. It starts from x1, x2, x3, x4, x5, x6 and x7. The signal goes from x1 to x7 and there's only one forward path, and it is given here. The forward path is given as the be careful about the terminology. When we say forward path, what we mean is we'll say along the nodes x1, x2, x3, x4, x5, x6, x7 is the forward path. And what is the forward path gain? It is the gain along that path. So if you look here, the gain here is 1. Then there is a gain of G1, G2, G3 and G4. There are 4 gains are there. So what is path gain? Path gain is G1, G2, G3, G4. And how many loops are there? Loops, there are 2 loops. We know about loops. In the last part also we saw the loop. This is one loop. This is the other loop. So there are 2 loops. What is the loop gain? This for this loop, the loop gain is G1 H1, and for this loop it is G3 minus H2. You note here it is minus. So we have only summers. So if you want to get the difference of signal, we will put a minus along the transmittance. So there are 2 loops and 2 loop gains. How many non-touching loops are there? This loop 1 and loop 2 are non-touching. So that is an easy question. So now we will eat the cake. The main part, the Mason's gain formula is here. So what does the Mason's gain formula says? It says T of S, the overall transfer function, is equal to sigma k is equal to 1 to n, sigma k is equal to 1 to n pk delta k by delta. So to understand this formula, we should know about all the terms in this formula. So the first term is n. What is n? N is the number of forward paths. N is the number of forward paths. What is pk? Pk is the gain of the kth forward path. What is delta? Delta is the determinant of the graph. So we have a signal flow graph. Delta is the determinant of the graph. So what is delta? How will we get delta? Delta is 1 minus sum of all loop gains plus sum of product of all combinations of two non-touching loops minus sum of product of all combinations of three non-touching loops plus so on and so forth. What is delta k? It is the cofactor of the kth forward path. That is, if there are two paths, then we will have P1 delta 1 plus P2 delta 2 by delta. So P1 is gain of the first forward path, P2 is the gain of the second forward path, delta 1 is cofactor of the first forward path. We know delta. Delta is the determinant of the graph. So you can get delta k by removing all loops touching the kth forward path. So what is delta 1? You remove all loops touching the first forward path. What is delta 2? You remove all loops touching the second forward path.